So you say these little things can build things like protons and neutrons? Can you explain that? And it still gets stuck to the fabric?
Great question. Yes, that's exactly what the model suggests. Think of these tiny blips, these little quantum appearances and disappearances, as the smallest building blocks. When several of them organize into stable tension structures, they form what we know as protons and neutrons. Each of these structures has something called a stuck point, which is like an anchor holding it to the memory fabric. That stuck point is what gives the particle its mass. The proton, for example, is modeled as having a barbell-like tension stretched across the Higgs field, anchored at one end. That's the stuck point you mentioned. Would you like me to walk through how 3 quarks fit into that picture?
Yes, I would.
Okay, here's how I'd explain it in the same teaching style. Let's take it one step further now. If you zoom into a proton or a neutron, you'll find they're made of 3 even smaller things called quarks. That's what science tells us. But what I'm proposing adds a new layer to that story. In my model, each quark is actually the visible tip of its own little Arnie. So inside a proton, you don't just have one Arnie, you have 3, all crammed together. Picture it like this: 3 little tessy ends, the matter sides, packed into a tiny space, all interacting with one another. But what holds them together? That's where the tension comes in. Each of those 3 Arnies is still anchored to the memory fabric by its stuck point. That tension across the Higgs field is what binds the whole thing into a stable structure. It's like 3 balloons, each tied to the same anchor below the floor. You can see the balloons bobbing around above the surface, but the strings go down through the floor to where they're tied off. You never see the anchor, but it's the reason the balloons don't float away. So the proton isn't just a blob of particles, it's a tension structure, a bundle of Arnies locked together by invisible stuck points holding tight to the fabric beneath our universe. That's what gives the proton its mass, its stability, and its ability to build everything else: atoms, molecules, life itself. And the neutron, same idea, 3 Arnies packed together. But in the neutron, the antimatter tension is balanced in a way that makes it just a little heavier and less stable when it's on its own. But inside atomic nuclei, protons and neutrons work together, stacking their Arnies, sharing tension, and building the very fabric of matter as we know it. Would you like me to carry on and explain how this scales up into atoms like hydrogen or helium?